another concept called as Venn diagrams. How do Venn diagrams work? Venn diagrams is simply, when we say Venn diagrams, Venn diagram. Venn diagram is the representation of sets in rectangle and circle or closed curves. Rectangle is always the universal set. Circle, these are always the subsets inside the universal. Sets inside the universal. If for this same question, if we have to if for the same question we have to draw the Venn diagram for this particular for this particular question, if you have to draw the Venn diagram, so how this will gonna work? We have already got the elements here. What is there in universal? What is there in P? What is there in Q? So these elements would help us in finding the making the Venn diagram. So Venn diagram is always a rectangle representing the universal, and inside the universal you have to show set P and set Q. Now always draw the set which is having the largest number of elements. P has 6 elements and so do Q. So they here in this case they have equal number of elements. So you can draw any one first. That doesn't make any difference. So if you draw P first, this is set P represented by a circle. And for set Q, you have to see if there is anything common between the two sets or not. So if there is anything common, you draw the second set showing some overlap. Since we do have the intersection here, P intersection Q exists, so we have to show the common region. Always remember this part is the common region for the two elements. This is P intersection Q, the common region. So we do have common elements here. We have already found P intersection, and P intersection Q is this 2, 3. So always remember whenever the Venn diagrams are to be made or filled, you always start from the intersection. So this has to be the very first step to fill up the Venn diagrams or make the Venn diagrams. You always start filling the Venn diagrams on the intersection. So 2 and 3, the first things to be filled. Next, you fill the remaining elements of the two sets. So for set P and Q, 2 and 3 are done. Now you fill the remaining elements. So for P, the remaining elements are 5, 7, 5, 7, 11, and 13. So 5, 7, 11, 13 all filled. You keep on crossing them so that you don't miss out any. And for Q, we have 4, 6, and 12. So 4, 6, and 12. Once you have filled the elements inside the set, now you fill the region outside the set. Outside the set, the elements are left are we have 1 not filled, 2, 3, 4, 5, they are 6, 7, they are filled. 8 is not filled, so 8 will go outside. 9 will also go outside. 10 is not filled, so 10 will go outside. 11, 12 are there, 13 is also there, and then last 14 will go outside. So this is how we fill the Venn diagrams for the sets given. Okay, let's solve a few questions from the past paper. Okay, here it says the universal set, this is the universal set. Universal set, this is given as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A is odd numbers, set B is multiples of 3. So it's always better to list down the elements first. Odd numbers. Odd numbers we have is from for this whole universal set range, the odd numbers are 1, 3, 5, 7, 9. That's it. Multiples of 3. So you look for the 3's table and you have to remain within this range of universal. So 3, 6, and 9 only. Okay. Part A, complete the Venn diagram to illustrate this information. So completing the Venn diagram, as I said earlier, you always start from the intersection. This is the intersection, the common region between the two. A intersection B, this is. So the common elements for the two sets are 3 and 9. 3 and 9, these are the common elements. So we're going to fill 3 and 9 first. And now the remaining elements. For set A, the remaining elements are 1, 5, 7, 9. For set B, we have the remaining element as 6. And the elements which are neither in A nor in B would go outside the set. So we have now 2, we have 4, we have 5, 6 are there, 7 is there, 8, and 10. Yeah, so they will go outside. So this is how we complete the Venn diagram. Part B, we have to find n of A union B. N of A union B means we have to write the count of A union B. So for that, we need to find A union B first. A union B is combining the elements of A and B. If we may combine A and B here, that would give us 1, 3, 5, 6, 7, and 9. This is A union B. And then N of A union B has to be their count. So there are altogether 6 elements there. So the answer is 6. List the elements of A intersection B complement. So for that, you write elements of A first. A, it's 1, 3, 5, 7, 9. Intersection B complement. So B complement, the elements are 1, 2, 4, 5, 7, 8, 10. So 1, 2, 4, 5, 7, 8, 10. And now you look for the intersection. The intersection, the common elements for the two sets are 1 is there, 5 is there, 7 is there. So 1, 5, and 7. 1, 5, and 7. These are the common elements here to be listed. Is this all clear?
Yes, sir.
So this was all about bit of sets.